No, two. I was wrong. Oh, yeah. We'll talk after the Friday. So we have to not sure we're gonna really great stuff. Answer. All the three of us are factors. Which one is it? Oh, yeah. Victor, welcome.
Thank you. And thank you so much again. I know it's already a long evening, so bear with me. Today, what we wanted to talk about, there were a lot of questions raised at Alma meeting about how we came up with the capacity versus condition assessment for the existing plant. So today I wanted to dive a little bit deeper into those options and walk through each of the hydraulic capacity as well as the process capacity question. So before I get started, the criteria that we used for our capacity evaluation is based on four main things. One is all the flow conditions were obtained or received from the phase 2 facility master plan that was developed in 2024. That's the numbers we use, the flows as well as the loadings coming into the wastewater treatment facility, number one. Two, we assume that all four alternatives that we are evaluating under our study would meet the same level of service, that they would meet the current treatment standards, the same permit goals that the current wastewater treatment facility number one has. Third, all four alternatives would use the same solids facility as well as the chlorine disinfection processes, which is gas chlorine and gas SO2 disinfection processes. And lastly, but not the least, all alternatives would comply with Chapter 217 of TCQ's regulatory requirements for redundancy as well as capacity. And also, I wanted to make sure that everyone understands all four alternatives are being looked on the basis of 50-year planning horizon. So from 2025 to 2075 is what we are looking for each of the alternatives, from alternative one, which is repair in place, to the alternative four, which is the MBR option. So let's talk a little bit about, I know there were questions on the applicability of Rule 217. When does it apply and when it does not? This comes directly from TCQ subchapter A, Rule 217.1, that treatment units that are altered, constructed, or re-rated with plans and specifications received and approved by the executive director after the effective date, which in this case was August 28, 2008, of the amendments to this chapter. This is the 217 chapter. And what does that alteration or alter mean? This is the definition, again, out of the TCQ's chapter 217.2. Whenever you're replacing a treatment unit in a treatment plant, or you're modifying a treatment unit in a treatment plant, whether it's the capacity or the intended function of the process or the process itself, the mode of operation or the configuration and the design changes. Any of these major design assumptions changes, that automatically triggers Chapter 217 rule implications versus the grandfathered Chapter 317 rule. So when we started looking at the existing wastewater treatment facility number one, our first task was to assess the treatment plant. And there were some questions again asked about what does it include? What does the assessment include? The assessment includes both the condition of each of the asset at the wastewater treatment facility number one, but also the capacity of each of the assets. And when I talk about capacity, I'm talking about both the hydraulic capacity, which is basically how much water can move through the plant or each process without submerging the weirs, and the process capacity of each of the process areas to make sure that the wastewater is getting treated to the right standards as designed by that particular process. So when you take into consideration both the condition and the capacity is what we look at the entire assessment of the wastewater treatment plant. So let's first talk about the existing hydraulic capacity. What was the existing hydraulic capacity of the plant? This graph shows you the historical 2-hour peak flow through from the time January 2016 to January 2025 over the last 10 years. Again, you can see 7 instances where the flows have exceeded the permitted 18 MGD flow that is for the wastewater treatment plant 1 permit. And 4 times it exceeded over 24 MGD. On the left-hand side, you see the SGRA's letter. So every time there is a flow that exceeds the permitted flow, SGRA is required to send a letter out of notice of non-compliance to TCEQ. And that is an example from the May event that happened where it was 28 MGD was the flow that SGRA saw at the wastewater treatment plant 1 on May 2nd, 2024. That is the letter that went out to TCEQ for the non-compliance. Historically, as you can see from this graph, even though the average flow at the plant has been 3.1, 3.2, 3.7 over the last 10 years, the current peaking factor, the peak 2-hour flow, is 7 times to 8 times what the current average daily flow is. So I wanted to emphasize that the 28 MGD that Freeze and Nichols, the master plan recommended, is a real number, that the plant is seeing that high peak flow, regardless of what the average daily flow is. The plant is seeing very high, large peak 2-hour flows. So when we look at the hydraulic capacity evaluation, we used, Carollo has our own hydraulics, like any other engineering firm, we have our own tools. We use the hydraulics, which is an Excel-based tool that calculates what the water surface elevations would be as the water moves from the stream. We start at the back end, the stream, water surface elevation in the stream during a 100-year flood elevation, and walk our way back to the head of the plant. And we follow the flow of the plant. This table shows you different process units for the wastewater treatment plant and the hydraulic capacity of each of those process units and where the deficiencies is. And the last column shows you the order of submergence or the order of failure, which is the first weir to get submerged. So as you can see from this table, at 15.7 MGD, the secondary clarifier effluent weir gets submerged, which means that there is a bottleneck between the secondary clarifier and the filter influent. After that, at 17 MGD, the aeration basin splitter box weir is submerged, followed by 19.3 MGD, the effluent weir, the entire partial flume is 100% submerged. So these are the calculations we do to come up with what is the hydraulic capacity of each of the process areas as the water flows through without submerging the weirs.
What do you think order of submergence? Can you explain that a little?
So which is the first weir, or which is the first process area that gets submerged? So the first weir elevation, or the secondary clarifier effluent weir, is what gets submerged at 15.7 MGD, because the filter influent weirs are higher. So the water has to maintain, when the water is flowing down, if the filter influent weirs were at a lower elevation, the secondary clarifier effluent weir would not be submerged. So we run the calculations from the stream all the way back to the head of the plant. So in other words, this is the graph that I know you all saw at the All Mud meeting that shows you the hydraulic capacity. Again, it is showing you how much water can move through each process area without submerging the weirs. The black line, as I told you guys last time, is the permitted 2-hour peak flow of 18 MGD. And the orange line is our evaluation criteria peak 2-hour flow of 28 MGD.
That 28, is that a 2-year, 5-year, 10-year average or what?
It is the peak 2-hour flow.
Peak 2, but over what period of time?
Per day, the peak 2-hour flow at a plant at any given point. So that was the hydraulic capacity. Now I wanted to walk you all through the existing process capacity. And I'm going to go each process by process. There is a lot of data on each of these slides, so bear with me, please. We'll start with as the water comes through, is the raw influence screening, the pre-treatment. That's what it's called in SRA's CMMS system. It's a mechanical screen. It's a Headworks International manufactured screen. It was installed in 2013, and it's one screen with a screen opening of 3/16 inch. And the capacity based on the manufacturer's recommendation and their manual, it's 24.1 mgd. So that means 24.1 mgd can flow through those screens to be effectively taking out the rag that it's supposed to take out. The condition, I also added the condition data that's in the orange boxes. The concrete is in a very bad shape. The channels are, it is very similar to the lift station that you all heard about at the last All-Mud meeting. Aggregates are being shown. So the concrete would really need to be repaired and rehabbed now. And the screen, since it was installed in 2013, we are looking at 15 to 20 years replacement timeframe on just the screen. Going on to the raw influent pumping or the lift stations, there are 2 lift stations at the wastewater treatment facility, 1 and 2. They are both non-flux centrifugal pumps. Flight is the manufacturers. The year installed at lift station 1 was 2001, and the most recent repair that was done at lift station 2 was 2018. There are 2 pumps at each of the lift stations, and that's the GPM capacity of each of the pumps. And the farm capacity of the entire, both lift stations together. And when I say farm capacity, TCEQ defines farm capacity as with the largest pump out of service. What is the capacity of pushing the water out of that lift station with the largest pump out of service? And so the farm capacity of the influent lift station at the wastewater treatment plant 1 is 16.1 mgd. Now, again, the conditions are shown in the orange boxes. The MCC and the VFDs need to be replaced in 10 to 15 year timeframe. The instrumentation control replacements are recommended within 5 to 10 years, and pump replacement also within 5 to 15 years. We also recommend performance evaluation done on those pumps because, again, the information we have on the pumps is based on the O&M manuals and the plate data from the pump. But we do not have a drawdown curves for those pump stations. So we recommend that. The plug valve replacement is within 15 years, and the building itself would need to be replaced in 20 years. But as you talked about at the All-Mud meeting, the wet well is in a very poor shape. We only looked at lift station number 2, but we assume the same is true of lift station 1 because it's this very similar corrosive environment. That the concrete repairs and rehab would have to be done right away. And then replacement, looking at full replacement in 20 years. So this graph again shows you the dark blue bar, the light blue bars you've already seen is the hydraulic capacity. The dark blue bars are now the problem capacity, showing you how much water can flow through those screens and lift station to be able to treat what the screens are supposed to treat it at. So for the influent screening and lift station replacement, there are, as you all already have heard multiple times, there are extensive concrete repairs that are needed at the lift station and at the channels of the influent screening facility. We estimate about 6 months of repairs because the plant has to shut down. They have to do scaffolding to go down their deep lift stations. They have to do the concrete repair coating. Concrete needs curing time, right? So it does take a long time. While all this is happening, the plant has to stay in operation. They only have one screening facility and the lift station. So if they do take this down for repairs, now they have to provide bypass pumping to be able to pump it directly to the aeration basins. The existing electrical building I mentioned last time at the All-Mud meeting does not have room for additional VFD. As you already saw, the existing lift station does not meet the firm capacity that is needed out of it. So to accommodate that additional pump, you need a VFD, but the existing lift station electrical building has no room to provide the VFD. So we would have to build additional building for the VFDs. And from what we understand, there is also future collection system consolidation project is also being looked at potentially, where they're combining a couple of lift stations which would again result in a deeper lift station, a deeper interceptor. Given all those conditions, we are recommending a new lift station and a screening facility at the site, so that the plant can stay operational while the construction is going on without the challenges that we talked through. So this is the site plan.
Can I ask you a question? You mentioned that if you did try to repair, I think number one, you'd have to go to bypass pumping. What are the implications of bypass pumping?
So the bypass pump, one, you would have to rent the pump and have to install a temporary piping along the site. You would have to run the pumps 24/7. So you would need to man it 24/7 too, because again, it's not tied to your SCADA system. So you will need to man that. You will have to have fuel consumption that the bypass pumps required. You also would require, since right now the flow goes from headworks to the lift station to the grid system. Now, in order to move the water from bypass pumping to the aeration basins, you cannot move it to the grid basin. So you would have to get a temporary grid system unit as well for the 6 months for the duration of the repairs that pushes the water into the aeration basin. So there is a lot of challenges. Plus, you have to build a new electrical building to house the VFDs of the new pumps.
Thank you.
So this site plan shows you in red the existing, that's where the 1 is the influent screens and 2 is the influent lift station. In red hashed area is where the existing screens and the lift station are. We are recommending that you build a new screening facility and lift station north of the site. The third one was the magnesium hydroxide tank. We did not see any major concerns with that tank, so we are just keep asking SRA to keep that remain in place, and the MAC tank would be replaced in 30 to 35 years timeframe. Grit removal, it's a forced vortex system by Smith and Loveless. It was installed in 2017. There is only one grid basin. And what that means is SGRA cannot take the grid system down for repairs or cleaning or any maintenance purposes because they cannot shut it down. That is the only one system, one unit that they have. And the capacity of that grid system is 20 MGD, which means that anything over 20 MGD, the water can move through, as we saw in the hydraulic capacity, that there is hydraulic capacity in the grid system, but the grit will not be removed. Anything above 20 MGD, the grit efficiency of grit removal drops considerably down. The condition of the grid system, again, we recommend a 15-year replacement. The building would be in 25 years. That's where the grid conveyor you see there. And the grid tank, the concrete structure itself, replaced in 45 years. Instrumentation and control, all the equipment need to be replaced within 5 to 10 years. And that's a typical, all the INC components are usually 5 to 10 years life cycle. All the slide gates need to be rehabbed, replaced in 15 years. But as I talked about, again, the hydraulic capacity, the grid system can move the water through the grid system. However, it cannot take out the grid efficiently above 20 MGD. So there is a gap in the capacity.
When you're moving 20 to plus MGD, obviously you're under some kind of event. Is grit picking up or is it kind of going down? And
usually grid goes down.
Yeah.
At high flows, you would see a little bit of reduction.
Right.
But our recommendation for adding a new grid system, a second basin, was just for the redundancy purposes, because right now they cannot take down the grid system for any O&M purposes.
How do they handle that now? Since they can't take it down, they must have a way.
No, we take it down and we bypass. And so we just let all the grid just go through the pipes and the pumps and settle out the basins.
You have a bypass valve that you flip in.
Yeah, piping and everything else to go around it because it's inevitable. Something's going to happen. It's mechanical, right? So.
But as the grid goes through all the pipes, it causes corrosion because it is grit, right? So through the pumps and the basin, they have to clean it out. So
Cause corrosion or erosion?
erosion. So we are recommending a new second grid system as part of this study for the existing plan, again, for the redundancy purposes. Moving on to the aeration basins, it's a conventional aeration, a conventional activated sludge plant. There are 4 aeration basins. 2 were installed in 1970s and 2 in 1980s. However, there are only 2 aeration basins that are in operation. Aeration basin 3 and 4 are in operation. Aeration basins 1 and 2 are not in operation due to structural integrity issues. They have a lot of leaking, and so it was condemned. Aeration basin 1 was condemned to not have water go through. However, aeration basins 1 and 2 have a common wall, so they cannot use aeration basin 2 either. So right now they are down to aeration basins. The combined volume is 1.35 million gallons with a site water depth of 16 feet. The aeration basins, the minimum SRT, the solids retention time, is about 5 days. And our process model showed the MLSS, the mixed liquor range about 3,000 to 4,000 milligrams per liter cube. And the oxygen required to aerate this aeration basin is about 15,000 pounds per day. So the capacity of the aeration basins, only 2, as I said again, only 2 aeration basins are in service. So for those 2 aeration basins that are in service, the capacity is max month condition is 4.1 MGD, and the average daily flow is at 3.7 MGD. We are recommending that the aeration basins 1 and 2 be replaced right away to meet the current capacity of the plant. And 3 and 4, again, they would need some concrete repairs that we talked about and WJE talked about in the last Almond meeting, but the full replacement of aeration basins 3 and 4 is 20 years down the line.
You said you have to have 1 and 2 to meet the current capacity, but how long? They've been out for a while. Right? So how are they meeting current capacity if 1 and 2 are down?
They're meeting the capacity because the flows are lower at 3.1 MGD average flow, right? So if the
So they're not
plant
meeting which is saying they can't handle the 7 or 7.8.
7 or 7.8, they cannot handle that. So the plant, if the flows go anything above 3.7, they would have challenges at the plant. The aeration system is the multi-stage centrifugal blowers at aeration basins 3 and 4, again by Lemson. And there are 3 aeration blowers. The unit capacity at about 7.5 pounds PSI is about 4,000 SCFM, which is the flow rate of the air, and the process air required is about 8,000 SCFM. And this is based on the existing diffuser in our modeling, which is they currently have ceramic disc diffusers in basins 3 and 4. The current aeration system for 3 and 4 is sufficient for the aeration basin 3 and 4, but for aeration basins 1 and 2, when they are replaced, we will need additional blowers. The MCC at the aeration basins needs replacement in 10 to 15 years. The electrical replacement within 15 years. The instrumentation and control again within 5 to 10, and the blower and the motor only for aeration basins 3 and 4 would be within the next 20 years. This is the graph showing again the capacity of the aeration basins. We do have challenges because the aeration basins 1 and 2 are out. We do not show the process capacity.
When was the last time 2 was run? Aeration basin 2
Was run.
was operated. Have you?
Say that again.
When is the last time aeration basin 2 was operated?
Probably the same time 1 was. They were
We
both
were taken down the
They've
same
been out.
time.
Both about the same amount
10
of time,
plus years.
10 plus years.
Isn't there something that the pumps or there's some things that are sitting up on the hill that could be used?
It could be set in the basin.
It's technically not
Last minute.
abandoned, it's kind of in some steady state or something.
That's correct.
Is that correct? But
It
they're,
could be set in if
Like a
the,
ship that can't leave port.
yeah. But you don't have blowers to work, so you don't have the blower capacity, even if you could get them operational. Is that right? Based on what you just said? Okay. Thanks.
The blowers are only tied to aeration basins 3 and 4. The
2 never.
1 and 2
Oh, that's
had
different.
mixer.
Yeah, that's right.
Would replacing 1 and 2 trigger 217?
For the new basins, yes.
Why?
Because you are, Toshio is my process guy. I'm gonna it'd be,
Go back to that slide, you're not changing the permit, you're not changing the function, you're not changing the
You
capacity.
may not be using it.
17 is a grandfather under.
So this is a construction of a new aeration basin that needs to follow 217. But it has a little, the aeration basins themselves have little implication in the difference between 317 and 217.
Well, does it trigger going to,
If you were repairing the basins themselves, it wouldn't trigger. There would be grandfathered. But if it's a new structure,
if you replace them, it triggers, repair does not trigger? Okay.
That only affect, the trigger would only affect the, when you spoke before, you said if we rebuilt the lift station, we'd only have to bring the lift station up to current code.
So
So what about the aeration basin?
if you build the new lift station, the new lift station
Have to
itself
meet.
have to meet 217.
Right.
The new aeration basins would meet 217, but not the existing other structures at the plant.
Like the clarifiers.
That's, yeah, you're not touching the secondary
So
clarification.
basically, as long as we only deal with that primary function of that unit, we just have to bring that up to code, but not the whole plant.
That's correct.
So that's the smallest discrete kind of thing you can think about with getting, having to comply with the 217 is a single process unit, whether it's aeration or it's lift station or a clarifier. Is that right?
Right.
These pieces are kind of the smallest pieces that would get okay. Thanks.
So again, this is the site plan showing you the aeration basins, the red box in checkered hatched one, number 5, is the existing aeration basins 1 and 2. That would be replaced by the new basins that are in orange, which are number 5, and a new blower building for those aeration basins 1 and 2. So moving on to secondary clarifiers, there are circular clarifiers, 3 of them by Envirex is the manufacturer. 2 clarifiers were installed in 1982 and 1 was installed in 1994. All 3 are 87 feet in diameter with a side water depth of 10 feet. And when we do our process calculations, we look at several different ways to calculate the peak 2-hour flow capacity through the clarifiers. First is the hydraulic retention time, HRT, of 1.8 hours. So when we look at that, the peak 2-hour flow capacity using HRT based on TCQ's chapter 217 is 17.3 MGD. The peak 2-hour flow using the surface overflow rate of 1,200 gallons per day per square foot of the clarifier is about 20.8 MGD. However, because they both were lower than what our desired 28 MGD was, we looked at the state point analysis, which looks at the SRT, the solids retention time in the clarifiers, and we came up with 21 MGD capacity of the clarifiers. The INC, again, same, the condition-based assessment, the INC equipment have to be replaced within 5 to 10 years. The butterfly valves within 5 years. The concrete repairs, as was talked about in the last presentation, needs to be coated and repaired, all 3 clarifiers. And then the full clarifier replacement would be done for the 2 of them that were installed in 1982 would be done in 20 years, followed by the last clarifier, which is the newest clarifier in year 2065.
These are mechanical devices, right? They don't really have a 50-year life, most of them. Pumps, butterfly valves, pumps, valves.
Concrete itself,
Concrete is,
the clarifier mechanism is
Mechanisms do
20 to
not.
25 years.
so I remember reading in the 2023 10-year plan that you basically replace all the mechanicals and mechanicals suddenly have a 20-year additional life. Is that?
Oh, so yes, the mechanical life is about 20 years. So any pumps, clarifiers, valves is about 20 years is the right life. Sometimes you can go up to 25 years as long as the structure.
So as long as the structure's okay, then the investment in a new mechanism is appropriate. So in this case, you guys said the clarifiers have a 20-year concrete, at least a 20-year
Yes.
concrete life. And so if we replace the mechanicals, we're basically timing them both to
Yes.
expire at 20 years, something or not.
There are also RAS pump associated with these, the return activated sludge pumps associated with each of these clarifiers. There are 4 pumps. There are self-priming centrifugal pumps by Gorman-Rupp. Each unit capacity, each pump capacity is about 1,600 gallons per minute. They were installed in 1980s. The farm capacity, again, with the largest pump, in this case, all are the same size. So with one pump out of service is 4,800 GPM. The condition-based assessment, the pump and the motor replacements are within 5 years since they were installed in 1980. The RAS building itself is 40 years and the VFD is within the next 5 to 10 years. This is the graph showing again the process capacity of the secondary clarifiers. As you can see, there is some delta that we talked about, that the capacity of the clarifiers currently do not meet the peak to overflow condition criteria. So right now on this one site plan, I am not showing any new clarifiers because I want to go back towards the end to show how we can potentially come up with that additional capacity. So for now, we are suggesting that we definitely need to repair the concrete as we had talked about in the last presentation for the clarifiers as well as the RAS pump, the building. And we'll talk about how we meet the capacity. The filters, there are 2 filter basins, but it's a cloth media filter basins by Aqua Aerobic. They were installed in 2015. The basins themselves were constructed in 1980. The loading rate, the gallons per minute per square foot of the filter media itself is about 6.5 GPM per square foot. And the peak 2-hour flow capacity per basin is 17 MGD. And the firm capacity means with one basin out of service, the firm capacity of the filters we are looking at is 17 MGD. And the hydraulic capacity, as I talked to you guys in the hydraulic capacity section, the hydraulic capacity of the filters is less, 15.7 MGD than the process capacity because of the filter wear, influent wear being higher. So if you lowered it, you could potentially gain the additional capacity. The condition-based assessment, the same INC equipment being replaced within 5 to 10 years, the pump and the motors within 15, all the slide gate replacement, again, mechanical components in 15 years, the concrete tanks themselves within 40 years after the repairs are done, as well as the media replacement that is scheduled. The manufacturer has recommended to replace the media, so that needs to be done now. This graph again shows you both the hydraulic and process capacity of the filtration system at the plant. Graphically, the number 9 is the 2 filter basins that we are recommending the concrete repair be done. And again, I will show you how we can talk through the additional capacity that's needed towards the end. The last part in the liquid process is the disinfection system. It's a chlorine contact basin used, SRA uses the chlorine gas to disinfect the wastewater, treated wastewater. There are 3 basins. 2 of them were installed in 1995 and 1 was installed in 2004 with a combined volume of 0.27 million gallons. And the side water depth of the basins 1 and 2 is 10 feet and the chlorine contact basin 3 is 9 feet. The peak 2-hour flow capacity of the chlorine contact basins with all 3 basins is 19.7 MGD using the contact time of 20 minutes, which is the TCQ required contact time needed for the water to have in touch with the chlorine gas. The PVC liner was installed in 2004, but as we again talked through the last presentation, there are some serious concerns in the chlorine contact basin structurally. So we do need to do those concrete repairs, replace the baffle wall that we showed last time as well. The buildings would need to get replaced within 25 to 30 years. The instrumentation and control equipment within 5 to 10 years. Again, the graph showing you the capacity, both the process and hydraulic capacity of the chlorine contact basins. The site plan shows you the number 10 are the chlorine contact basin and the building itself, the chlorine and the SO2 building. again, we need to go in and do some concrete repairs at both basins and the buildings. Effluent meter, which is a final, this is where the partial flume, it's a 36-inch wide throat partial flume ultrasonic meter, and the flow capacity is up to 32.6 mgd based on the record drawings that we have for the facility. Again, as Squeezy and WJ talked about in the last assessment, last meeting, there is some exposed aggregate in that partial flume. So we would recommend repairing that concrete now with the full replacement within 35 years. And this graph shows you the capacity of the effluent meter. And the reason you do have the proper capacity of 28 mgd, hydraulically, as I mentioned earlier, at 19 mgd, the partial flume gets completely submerged, which is why the capacity, the hydraulic capacity, is lower than the process capacity.
From a process standpoint, what's the impact of that?
You can't measure and then the flow that's leaving the plant accurately. Once a partial flume is submerged, you
Going
would,
back to your slide though, I thought it said, so I'm confused about, one more back. The maximum flow of 32.6.
it's so the flow can go through it. However, we do not have the right data.
Oh, okay, you
You
don't
can measure,
it, but
you
it will
can-
process.
You can push through it. We just don't know accurately how much water is going through it.
Okay.
Because the stream level has also risen, so we just don't know how much water is going through. So we are again just talking about repairing the concrete at the effluent meter. The storm pumping or the effluent pumping, there are two outfalls as you already know. Vertical turbine and centrifugal pumps. There are 6 on the outfall 1 and 2 at outfall 2. We do not have a lot of information on the outfall 2 pumps, but we do have the nameplate capacity for the outfall 1 pumps, which are 5,000 GPM each. Condition-based assessment, we are looking at replacing the pumps and the motors within 5 years. Blower and the motor replaced within 5 years as well, with I&C equipment being replaced within 5 to 10 years, and the basin, the partial flume itself being replaced within 35 years. So moving on to the solid side, this digestion. There are 3 aerated sludge tanks. They were all constructed in 1987. The combined volume is about 0.73 million gallons with a side water depth of 18 feet and a 23.5 feet for digester 3 or the sludge holding tank 3. We look at the hydraulic, the retention time at the max loading condition, max month conditions. It's 2 days. So the sludge is held for 2 days. Without digester 3, or they could hold it for 3 days with digester 3. Currently, at the current flows, and this is, by the way, at peak flows, right, or the max month condition. Currently, SGRA uses 4 days HRT for the sludge holding tank. So our criteria for planning was using 4 days of holding time for the sludge holding tanks. Condition-based, again, the same I&C, MCC, all has to be replaced within 5 to 10 years. The blowers as well in 5 years, pumps, motor within 15 to 20 years, and concrete tank itself after the repairs are done within 20 to 25 years. So based on the HRT of 4 days that the SGRA's criteria is currently, the number 13 is the repair of the existing concrete, but we do need to add another sludge holding tank to meet the HRT of 4 days for SGRA.
Can you go back to that slide? Help me understand peak flow, the 2-hour peak flow, but you're saying that peak flow is going to last for 4 days?
No, so currently, right now, SGRA uses 4 days storage time. Is that correct? Based on our model.
Yeah, so here the difference is that this is the white spot in the pipe for SGRA in terms of they have to put the sludge somewhere before it goes to dewatering. And the sludge production sometimes outpaces the dewatering, so they need this amount of time for the sludge, so it's divorced from the flow. This is just based on the sludge flow.
By the way, this is Toshio Shimada. I apologize, I didn't introduce him, but Toshio is our process expert. He ran the BioVin model to run all these process calculations.
Normal operation at a facility like this?
Yes, so whenever you have a dewatering, because you can't push all the solids through the dewatering, so you do have a white spot in your system to hold sludge.
But that's a tank. That's nothing.
It's a tank.
It's a
It does have diffusers, blowers to keep it aerated, because otherwise it goes anaerobic conditions and that would not be good.
Is this the same presentation we saw 3 weeks ago?
You saw the results
Get the
of
details.
this, but now I'm showing you all the details on how we got there.
Great, this is great. This is great information.
Because it was already, there was so much information last time, so we tried to condense it. And I apologize again, this is all work in progress all the time. So there might be some questions that you all asked that I may not have answered today, but we are working through that process.
Eric, could you get a copy and send it to us? We can.
I will email Eric you the copy once tonight. Again, the site plan showing you the sludge holding tank as well as the odor control system that would be needed. The chlorine building we already talked about, that would be replaced within 30 years. It does not need to be replaced currently. The dewatering solids, it is a 2-meter belt. It's a belt filter press, a 3-belt system. There are 2 units currently at the solids building. The capacity of those belts, belt filter press, is about 1,800 pounds per hour. So about 300 GPM per unit capacity per belt. So that is enough adequate capacity to handle the flows that we are talking about for the solids generated by this plant. So we do not need to make any process changes or add any additional belts at the solids building. But condition-based, again, you would need to replace all the mechanical INC equipment within their 5 to 10 year or 20-year timeframe, and the building itself within the next 40 years. This is again showing you the dewatering building. We are not just some repairs in the building itself, but nothing major. And then the SO2 building that would get replaced in 25 to 30 years as well. Again, no major changes at the SO2 building either. So some other condition-based replacement that we haven't talked through in each process area are these building. The process water that was installed in 2000 needs to be replaced within the next 5 years. The process water MCC, not the process water pumps itself.
What's the MCC? Sorry.
That's the electrical control center. So the electrical MCC needs to be replaced within the next 5 years. The process water multipurpose building, this is probably one of the worst buildings at the site. Foundation issues, a lot of challenges, significant cracks. We truly recommend that building be replaced within the next 5 years. Well, it is, again, we didn't do any structural WJ analysis at the building, but it is significant from what we see. There is significant water holding through the cracks as well. It's underground, below ground. The process water pumps and the motors, they need to be replaced, rehab within the next 10 years. Storage buildings, again, we need to reassess in 5 to 10 years and potentially replace within the next 45 years. Similarly, the fuel system, the SCADA shop, reassess, and the main switchgear, they need to be reassessed in 5 years, and potential replacement, full replacement within the next 35 years. So I know this is, yes, sir.
So when you put this all together, the process and hydraulic capacity evaluation, we had the permitted capacity, the evaluation criteria is the light blue and the dark blue bars, right? The recommendations on that you just went through, which is a great presentation. All the repairs does not do anything to capacity, right? So Or is it the replacement side when you get to that you actually do something with this capacity? I know you have some other capacity things you're gonna talk about, but in general, those bars don't really change with the condition assessment recommendations you've made. Is that correct? Or
So the condition is just to keep the concrete in place currently as is. Capacity is just looking at whether you're adding pumps
Right.
or clarifiers or filters or things like that of nature. So this is again a very busy graph. I apologize, but it walks you through each of the process areas, from influence screens to the stormwater pumps, dark bars being the process capacity of each process area, and the light blue bars being the hydraulic capacity. The orange is showing you what is condition-based replacement. So influence screens and influence lift station, as we recommended, based on the condition and the time it would take to repair and shut down the lift station and bypass the pumping. We are recommending a new lift station, a new grid basin. Again, that's based on not only condition, but it's also redundancy requirement. And then the replacement of aeration basins 1 and 2 to catch up to meet that gap that we have in the process capacity is just replacing the existing aeration basins 1 and 2. It's a condition-based replacement. The other 4, the secondary clarifiers, filters, chlorine contact basins, and the effluent meters all require additional capacity. How you achieve them? One of the examples you saw last time was adding additional 2 clarifiers, associated RAS pumps, filters, and chlorine contact basins. This assumes that there was no peak flow storage. We somehow need to push that flow through the plant and meet the treatment at the permit capacity or the permit limits.
So that's, let's go, can you go back to?
Can I finish my
Sure,
talk?
okay.
And then we can go, and if you have questions, because I think if I may not know what you're asking, but let me just finish my thought. So this is what you all saw. This was basically no peak flow storage. And as I said earlier, this is a work in progress. This is the worst case scenario that you would need additional basins to meet that treating the peak 2-hour flow that we need through the plant. We were talking with SJRA about different options already, but we weren't ready in the April all-one meeting to talk to you about it, which is showing you the peak flow storage. If you somehow stored that water through that plant that's moving through the plant, instead of going through each basin, you could get by without building that additional basins, but just having the peak flow storage tanks. And the benefits of providing the peak flow storage tanks is, 1, it optimizes your treatment processes, all the secondary treatment, the filters, the disinfection processes, and to not having to upsize them by adding additional facilities for the events that only occur once or twice a year. The existing clarifiers, filter, chlorine contact basins, if you do provide peak flow storage, would be grandfathered into your chapter 317 and not having to re-look at chapter 217. The third advantage is that there would be no need to modify your discharge permit. You could stay at your 7.8 MGD permit with 18 MGD peak 2-hour flow and just store that water at the site. And it provides SJRA staff, the O&M staff, the ability to handle the peak flows without incurring the permit violation or stressing the plant out during those cases. The biggest disadvantage is, and it is not an easy thing for the plant staff, but they do have to clean these tanks out after each time. So you can imagine when that flow, the raw wastewater is coming in, it's going to be full of gunk, right? Full of trash, rags. And so after every use, they would need to go in and clean it. That's one of the biggest disadvantages. So this is what the site plan would look like if you provided additional peak flow storage. So we would build potentially 2 peak flow storage tanks up north, right next to the lift station, the new lift station, that gets rid of providing additional clarifiers, filters, or the chlorine disinfection basins. And now, because you don't have additional chlorine contact basins, you do not need a new chlorine building or an SO2 sulfur dioxide building either. So this is one of the our recommendations. And this is just showing you the 2 options of alternative one, repair in place. One on the top is with no peak flow storage provided with additional facilities. And the second one is with the two peak flow storage tanks, which grandfathers in the clarifiers, filters, and the disinfection system. Sorry, do
Okay,
you have?
Very good. I mean, this is the missing piece that you added, okay, based upon some feedback and also work that Freeze and Nichols
So
had already done.
we have been working on this. We weren't ready to show you because again, as I said, there's a lot of work being done every single day. We are not sometimes ready to show you because we are not ready with the press. So we are showing you information we have in hand at the time that we did.
If you go back to your previous bar chart. Yeah, that one. So the 28 is still an artifact of triggering 217.
28 MGD is based on what the plant is seeing. If you saw that flow graph,
But it's not a requirement. It's not a permit requirement.
it is not, but they are violating the permit every time the flow. But yes, it is not.
Yes.
But they need somehow be able to store that water that is coming in. That's a reality, that water is coming into the plant.
Right. Well, you could have a discussion about how much money do you spend to avoid a permit violation every 4 years?
That is not a question, that would be a question for TCQ.
I got a
And
question about,
how much risk that SRA wants to take.
I gave you a
Oh, chair.
5-year history of the TECQ, basically the criteria of ammonia, BOD. I don't know, I handed it to you your first presentation. And I gave everybody a copy. For the last 5 years, there were several of these peak flow events in the past 5 years. But the quality of the effluent was always way below required maximums or minimums. How do you explain that this peak flow seems to be I call it a crisis, but when it finally goes through the plant, apparently the retention time and clarifiers and everything is, gets, in other words, you're picking a peak flow, but it's spread out over eventually enough time that it's able to treat the influent. And so anyway, tell me why we're all of a sudden trying to plan for this event. And more than likely, every wastewater treatment plant in Southeast Texas, when these huge events happen, they've got the same problem. So explain to me how this peak flow is able to be absorbed in the plant and generate quality effluent.
Well, each of the process units treat the flow that comes into the plant, right? So as I explained to you, if there is a gap in the process, if the clarifiers cannot take the job of the clarifiers is to take the solids that are in the wastewater to settle them down. If they cannot settle the solids down effectively, they are not doing their job. So what I showed you is there is a gap in the capacity. The clarifiers cannot treat the wastewater that it needs to do at that loading that is coming into the plant. And that loading that is coming into the plant is also based on the information that was approved in the 2024 master plan.
No, but the effluent quality beats all TECQ.
I think what you're noting is that when we get a violation, it is a quantity violation, not a quality violation. And the basic term that I would tell you is the solution to pollution is dilution, right? So the more storm water that comes through,
It is
Right.
diluted.
it's diluted down with the same amount of loading that it otherwise would have. So yes, chlorine, but the solution to pollution is dilution. So with more storm water that comes through that doesn't carry the BOD and the effluent that we would need to treat, you're basically getting stormwater through the plant. And so that's what's happening.
And sorry, go ahead.
I think, why don't you answer that question first before I ask mine?
Well, I was just going to add that all we are recommending is somehow the reality is that the plant is seeing flows over 18 MGD. And they are violating the permit every time the flow goes over 18 MGD. It is a truth, and that is 7 to 8 times the flow, average daily flow coming into the plant currently. So when those flows go up higher than 3.1 MGD, you're going to see even higher potentially. We don't know the future, but potentially there could be higher peaks if you use the same peaking factor of 7 or 8 times. Somehow there needs to be ability to either you treat the flow that's coming through the plant or you store it.
Or you reduce it.
That is the contractual question.
That's another issue.
That is another.
That's
yeah,
another
our
issue that we.
Criteria was,
about tonight.
yes, was based on the flows coming into the plant that was developed by the master plan.
Have you seen
Yes.
clients, just to, punch on that a little bit, have you seen clients who focused on, reducing the 24 to 15? I mean, obviously it's entering the system through manholes.
It's I&I. It is a lot of other challenges in the collection system itself. Somehow the water is coming into the plant.
Into the plant.
So if you fix your entire collection system, yeah, you may potentially see reduction. But that water somewhere has to go someplace, right?
And, right, if it doesn't come into our system, it's gonna go
Somewhere else.
downstream. It's gonna go downstream. So have you seen your clients focus on reducing that I&I, is it I&I? And how successful have they been in the past in focusing on that? Because to me, it's a height of the manhole. If that's, unless you have a crack.
It's not just the manholes, but it's a lot of other, it's not easy. By easy, I mean, a lot of municipalities do not have money just sitting around to replace the entire collection system. Collection system is huge. I'm sure, I don't know how many lift stations SGRA has, but City of Houston has 420 lift station. And thousands of miles of collection system force mains. If you replace the entire system, it would be billions of dollars for City of Houston. I can't speak to SGRA yet because I don't know the entire collection system.
How many lift stations?
How many lift stations?
We have like 29.
29, because we don't have lift station 15 anymore.
29 in wastewater treatment plant 1.
I think I can answer that question for you, David, as well, from my experience of serving municipalities as well. A lot of them will take a double approach, right? So they're going to make sure that they size their treatment facility and maybe have the peak flow storage, but they'll also then go try to tackle the I&I on the top end. And how successful are they on the I&I? It really just depends on how much money that they can put to it. So lining the pipes, you've got to find where over the years, people have tied in storm sewer systems into the sanitary where it wasn't supposed to, and tracking some of that down is very difficult to do. You may have groundwater that perches and then ends up in, and you can't find that until it rains and it perches and it sits there and then it gets into your line. So there's things like that that are very difficult to find outside of just lining the pipes and trying to seal the manholes, to your point.
But to add to that, WWA on your all's behalf is doing some sewer rehab.
Correct.
We have done some in excess of $40 million over the last 10 years. And so you can take it to a point and then, but you're still going to have 3Q, 4Q I&I in your system.
Right. And that is a standard in the industry to assume a big infrastructure, it's more like a 3, but when you're looking at things generally our size, it's a 4.
So
4Q.
3 would be 9. 3 times 3, is that how you do the math?
No.
No. So how do you do the math? We normally have passing 3.6.
3 times,
So
3.7, or whatever the permit is.
Whatever the permitted
Whatever
capacity is.
permitted.
Yes, sir.
21.
Yeah, so it'd be 21. Yes, sir. Or 4 in this case, which gets us to 28.
If TCQ,
Yep.
if TCQ does not have any data, they will say, okay, use 4Q.
Right.
So use your average daily flow time 4 times, that's your peak to hour flow, if you do not have any data available for a new plant or a new utility. For plants such as these, if TCQ looked at the data at the last 5 years, it would be challenging for TCQ. If this permit reopens, it would be challenging to get the 18 MGD peak to hour flow, which is why if you do potential peak flow storage, there is an advantage that certain facilities are grandfathered in. You're not opening up the permit. When you do open up a permit, there are risks where the flow conditions may change, even stricter regulations may come in.
Can you go back to the chart with the 2 collection tanks? I realize these are located, by their finger.
Yeah,
So
so
if we would adopt this model, a new lift station and 2 collection tanks and locate them strategically. Then in 20 years, if we decide to redo the plant, that investment is not lost, is it?
That's correct. I mean, this is again, just showing you graphically.
Right, graphically.
When you do a design, I would assume they would go through a proper design and layout where the tanks go. Just to keep in mind, right now we are showing the blue boundary is the existing property boundary. These tanks and the lift station and the screening facilities are just south of the northern boundary. TCQ does require 150-foot buffer for any process around any process areas, and that would count. So you would need additional. So again, you would have to lay these out during design
Right.
to the right
So Ed,
area.
you were able to get some land.
Right.
So how does that fit into that picture up there? That
One of the tracks is a 1.5 acre north of that blue line, or above the blue line in this case. It does not cover the whole area, but we have identified other tracks above that blue line also that need to be acquired. And those are on hold until we can kind of get a path forward.
So there's a way to structure,
That's
to make an investment,
Oh,
in
yeah.
which we retain the value of
Yeah,
what we spent.
that's correct.
Question.
Yes, sir.
The volume of these storage tanks, is there an estimate of that?
Yeah, it was 1.25 million gallon tanks each.
Each?
And
question.
acreage? How many acres?
How big is a 100-foot diameter tank? It's about 100-foot diameter each tank.
It barely fit in a 1.5 acres.
Barely fit 1.5 acres.
Yeah, early on, you described the submergence sequence, right? I think one of the early graphs, then you went through all the details of each process. Has the plant's experience kind of this plant's operational experience kind of validated that technical, evaluation you did, does that kind of match up with reality pretty well?
So I was asking Chris earlier on the 3 clarifiers, existing clarifier, have we ever overflowed the concrete?
Right.
He said, no, we came close on 3 or 4 out of the storms that Mira had on.
So we did verify with the plant staff. Every time we run a model, the model will say something, but we want to make sure it verifies. So we did talk to the operations staff to verify that there were submersions.
Okay, I figured as much, but thank you.
Okay, I want to get back to this permit, chemical permit, allowables. Talk about BODs and nitrogen, ammonia. Basically, we've had no permit violations in 5 years, right? Okay,
Permit violations for,
but it's my understanding, and I think Murray brought it up in our meeting, and I was kind of surprised that I thought there would be some kind of way to bypass the facility and go direct into the creek, but apparently it just backs up into the system. Is that correct? Okay, so when it backs up into the system, how much flow is at one of those peaks is actually coming through the plant? It's not. In other words, so to get back to anyway, they're testing one of these, wherever they test. And so it's meeting the specifications, whether it's by treatment or dilution. Will that be a correct statement?
it's
it's
by
either-
treatment only, by treatment, because the
That's not
water is
what-
going,
That's not what Connie just said. She says
she's saying,
pollution by dilution, right? Or whatever she said.
yeah, but what she meant is when there is high flows coming in, that means there's a rain event in the area usually. So when there's a rain event, a lot of water coming through, your BOD, your loading of that wastewater is going to be lower compared to your average daily flow conditions. That's what she meant by.
But the point is that it still meets the specifications of the discharge, right? BOD is still gonna meet, discharge, TCQ requirements, whether it's by dilution or, treatment.
Yeah, so you are meeting.
So that's good, right? Isn't that our objective?
Yeah, so we are, sorry, go ahead, Tosh.
Yeah, so real quick, I want to clarify. Secondary treatment does not treat the vehicle. So the water goes by, like Connie said, it's diluted effluent.
Right.
And this is a 2-hour event. And the samples that you're looking are a composite sample over 24 hours. So it would not be a violation in terms of the concentration. You're right. It is a flow violation, not a pollutant violation.
So when I'm talking about violations, it's only flow violation,
Okay.
not the permit quality.
But the really an objective of this whole process is to put quality effluent out or spec effluent.
It's,
In other words,
yes, and not have any permit violations. That was our.
which we haven't had any for 5 years on this.
So I want to be clear though, any violation we get, whether it's quantity or quality, is a violation of the Clean Water Act. So we as engineers, health, welfare and safety, for the law, we can't design to anything but to make sure that there's no violations. That is our job.
It's also in our contract. Makes sense.
Would be a fair statement, and every one of them would, like, we had 500-year floods in a row, 3 years. Every wastewater treatment plant in southeast Texas, probably in those 3 years, exceeded their peak flow permits. Would that be a fair statement? You guys are in.
Can't speak I can't speak in absolutes of everyone, Mr. Maggard. Many of them did, but what we didn't have is in those situations, the EPA coming and knocking on our door for a consent decree. But what is the thing is that they can at any time for any violation. And that is not an empty fear mongering threat. That is a reality.
City of Houston is currently under consent decree by DOT.
I don't think
Just-
we'll be in that situation.
All right, so I know it's been a long night for you all, and thank you so much
Thank you
for
very
any
much.
insight. But I do want to talk through quickly. There were some questions asked on the net present value analysis assumptions. What assumptions are we using? I will be honest, I'm not a financial lead. I have an entire finance team. They are not here today. So when we show you the entire analysis, they will be here to talk through that. But I wanted to quickly go through some of the components we would be using in our analysis. First is the discount rate. The discount rate is calculated using two parts. First is the 20-year treasury rate, which is a risk-free rate on risk-free or low to no risk investments. And the second is the equity risk premium, which is the expected rate of return above the treasury rate, 20-year treasury rate. So we looked at the current 20-year treasury rate is at 4.82% this is based off of April 15, 2025. And then the equity risk premium is currently at 5%. That is from the March 2025 update. So when you add those two up, the discount rate is 9.82% is what we are planning to use in our analysis.
And we're looking for confirmation that you all are okay with those so that they can conduct their NPV to bring back.
It seems high.
It is very high, very high. I agree, but these are the current rates. One other option is to use another,
We always use 10%.
oh, really?
Chevron did. I'm just saying,
But you're,
always
See, on the water
profit.
side, this seemed
Yeah,
really
it is.
high to us.
clearing your capital hurdle too.
You guys have got tax exempt numbers you should be using probably instead of actual numbers. In other words,
Which mean-
you sell
Yeah, I
tax
mean,
event.
if we're using district bond rates, and then of course Riverstory is a little different, but I'd say 5 to 6% would be district bonds. Now, revenue bonds might be a little bit higher. I know y'all can get Texas Water Development for it, but I'd say probably on the higher end would be around 6.
Yeah, the other indexes using the water, there's a water council. Their discount rate is about 7%. And so we thought about bringing that up to you as well, is whether we use a 7% or 9.82%. Higher the discount rate, lower the NPV.
So this is easy. Do a sensitivity.
Say what?
So do a sensitivity. It's a number. You change one number in the, so you do the base of 9.82 and do a sensitivity of 7.
say it again, Brett?
Use a sensitivity analysis, is what he's saying.
Oh, okay.
So you can see both of them, right?
Just out of curiosity, you have this equity number. That's not the the number we're paying on the loan amount, right?
This is just the equity risk premium as published.
Which a commercial event would use if they're making a decision to invest in a piece of equipment that has a stock, an equity
Right.
requirement to return to shareholders.
That is correct.
So that's a commercial.
Well, I would debate that your residents have an interest beyond just a governmental return.
No, I
Right,
understand.
right. It's their money. It's got a line that it's not stock, it's not, but they're the kind of shareholders. And I think they have alternatives to put their money to. So I know it's something to debate and discuss, right? That's all.
The other part of it is we went through in the strategic planning session, we're not stockpiling cash to buy down the cost of the project. It's all going to be bonds. Regardless of whether it's a repair in place or whether it's a new plant, we're going to go sell bonds for probably 3 tranches during the duration of the project. And I remember Mr. Lilac did quite a bit of analysis during the last go round and realized that because they are government bonds, the discount rate really wasn't applicable, is what I recall. Now, please correct me if I misspoke.
That's correct.
It's correct.
And is this the bond rate? I mean, this discount rate you used a year and a half ago? And that $50,000 special we bought?
I'd have to go back and look to see what they used.
I
But
don't believe
remember,
so, because this is the most
is
recent
the most
number.
recent.
So I understand we
wouldn't have used this.
the 20-year has changed.
but remember, you all signed off on those assumptions that Freeze Nichols used in that analysis.
What about the timeline? Are you going to address the timeline and the difference between 25 years and 50 years and how?
So all our alternatives are over 50 years. Each alternative is being looked at over the next 50-year cycle. So when the investments need to be made over that 50-year cycle.
So in the repair in place, if we've talked about that, extending 25 years of life, there's another investment sitting right at the end of that.
Right.
To get you, and then another 25 years, because all that has to line up to be consistent, right?
Yeah,
Well,
definitely. 25.
But so what you're doing here is basically deferring the investment for 25 years.
Yeah, discounted is not going to be a lot, but I think it's something you have to put there. It's, yeah.
Right, you have, I mean, obviously they have R&R data for equipment and mechanical equipment that you can plug in, that we're going to continue that. And then you have the concrete replacement, and then we can, not replacement, but repair. And then we can debate lift stations, holding tanks and all. As what do you need in the next 20, 25 years? And then the 300 million would then begin.
Or whatever it is.
Whatever it is. at
Future
that
value.
point.
I think we need to give some thought, though, to making sure we have the best economic analysis for current conditions relative to apples and oranges, where you say, well, on the alternative one, you get to 2060, you have to invest a big chunk of change. And that puts you at 50 years, you still have a lot of useful capacity in that plant. Whereas in the build new, you're going to have a lot less useful capacity, remaining useful life at the end of 50 years. So you got to be.
Yeah, you keep leapfrogging it and
Right,
continue
right,
forever.
right,
almost.
Right, so you
Right,
gotta,
I get that.
somehow, if you're gonna spend a bunch of money in 2060 versus spending it in 2028, you gotta be able to look at some credit assigned to you for remaining useful life at the end of 50 years.
So the last time we did this, we got a number out. And personally, I'd like to have a discussion about the cash flows. When you do a net present value, you have a cash flow.
Investment.
You see investment timeline. And I can digest that. I mean, really, I know if you have 2 investment devices, they both use 9.82, relatively, they're going to be the same. But I'd like to see the cash flow assumptions for each year or for each investment event.
Yeah.
You mean, so they plan on the $300 million new plant starting today. they're gonna, I guess you would use the bond, right? You'd have debt payment on the bond going down. And then if you use the 20 years, you'd have, you can debate what we want lift station, we want to do the concrete repairs. We know an R&R number for mechanical, electrical and mechanical, electrical. We could work that in to say, okay, this is what we normally experience over the next 20 years for repair and replacement. And we can start looking at the cash flow model. Last time it was kind of like, wham, we're done. And they flashed a big graph and, and I think we need to have more analysis than we had.
Yeah, so our plan is to, once we are not ready to talk about NPVs yet, we are still in process. Once you guys agree with these assumptions, we can start running our models. But yes, our plan is to walk you through all the assumptions and the process and the investment timing of the alternatives as well. Now, I want to also caveat, alternative one, giving you the investment profile is easier because we have the asset list, the
Right.
existing asset list. For alternatives, other alternatives, we are making assumptions. We don't have the actual asset list. So for example, we'll say, and we'll walk you through this approach in detail next time at the old MUD meeting, but if there's a clarifier, let's say 30% is the structural cost, 20% is the mechanical cost, and we are using those kind of assumptions to calculate when the investment needs to be made. But just wanted to make sure that you all are aware in this room what
But the other alternatives, I guess it's 2, 3, and 4, are basically use the word decommission the current asset and replace it whole. That's the membrane.
3 and 4 are. No,
Three and-
3 and 4, yeah.
3 and 4 are
2 is replace in place.
how we place in place, which is really because we thought we had to meet code for the whole plant versus an individual unit, which she says we don't.
No, that would be basically going in and meeting code, but replacing them every
One.
one at a time, and it'd be over an extended, longer period.
Like lift station, you come out 2026, like you originally proposed, that, over a 2-year period, build a lift station. And the cash flows would be associated with that lift station. It's easy to talk theoretical, doing this and that. I'd like to see a timeline with some discussion about what these cash flows, because that way you kind of build a model that we all understand.
Well, that'll flow into rates too, which our residents will care about, right?
Yeah.
Right,
Yeah.
right.
Were you about to show cost escalation too, or
Yeah,
inflation? Is that the next thing?
There are two things that will go into the NPV. One we talked about was the discount rate, and the second is the inflation index. We use two one is the ENR, the Engineering News Record, which looks at the labor, the lumber, the steel, as well as the cement index, cost index. And the second is the US Bureau of Labor Statistics, the Consumer Price Index, the CPI, which is the average change over time in prices paid in the urban consumer. So we looked at both those indices. Here is the 5-year inflation index comparison, for both the CPI on all services, CPI on just the water and sewer and trash collection services. And the last two are the ENR over all the US cities. And the last one is ENR Dallas. ENR Dallas is shown here because Dallas is the closest ENR index that we have to SGRA currently. That was the closest one we could show. So as you can see, this is the 5-year average. So we are recommending using 4.5% capital escalation factor inflation index.
Does that track kind of recent history of wastewater treatment plant costs kind of in the last, 5 to 10 years? It seems
It is low.
low.
Considerably low.
Considerably low,
Oh, yeah.
but it's also, we are not in that, after COVID, it just jumped.
Yeah.
It escalated very high. We are stabilizing, but we are not there yet, 100%. But based on these, as you can see in 2024, Dallas dived pretty deeply.
Yeah, negative. Right?
And when you look at the ENR, the 20 cities, 7 of them dived down. And we it's not based on labor, I believe, looking at the data, it's more based on maybe the mortgage rates, the treasury rates impact, the federal rates going up, the houses not being built, right? So there's a lot of things that have come up, but this is our best, using the most recent data, this is what we came up with.
But that
There was some-
Dallas 2021 is what you're talking about post-COVID, that 18.37 that
Right.
went through the roof.
Right.
You know, that went up and
We
then
saw
it
it here.
keeps going, right?
But
I know we had some data. Oh, sorry, go ahead.
I mean, you'll have a sensitivity on this.
Well, but when we start doing I mean, I can ask our finance guys how easy it is, sir. I don't know how easy it would be to do it. How many numbers they change and how much in the spreadsheet they can change it. But I'll get back to you.
Yeah, I mean,
You
you're
just tell them
gonna,
the
you're gonna need a higher number for the escalation, otherwise, you know, on sensitivity, otherwise it's gonna skew the entire MPV to make things done later cheaper. Because the cost escalation is gonna be
That's
slower.
really-
But that's reality, okay? That's why we're saying don't spend that,
Exactly true.
okay?
Well,
Things done.
as far as the cost
Yeah.
escalation.
Because remember, you build a plant today, it has a 50-year life, right? You repair, let's say it's half, 25-year life, and then you extend the 50-year life. So that plant has a 75 years out, this one has, so in most of these calculations, net present value, deferring an investment and maintaining it will most likely always be cheaper. I mean,
The only reason I brought it up was that we were presented with some information way back when that showed trying to find some comps on plants being built, you know, same kind of scope and scale and whatever. And 5%, 6% did not justify it. It didn't explain it, right? And so are we in an area here that's just going to break from these norms? You're the experts. Tell us what's going on in the marketplace. Is it regional? Is it US based?
It is more,
Right? There aren't enough plant builders around, so they're raising prices. I don't know.
there's a lot of construction, especially in this area. There is a lot of wastewater projects happening currently. I don't know if you've read on the news, the Chronicle, Houston is going through $4.2 billion East Water Plant expansion. On top of the Northeast plant that is getting completed on Lake Houston, that was a $2 billion plant. They now have the $9 billion consent decree. So just Houston alone, over the next 5 to 10 years, there is a labor, more that what we have seen is the labor shortage, which is not representative of the ENR Dallas index as much.
so where's the labor shortage coming from?
There's just too much work in this
Too
area,
much work. Okay.
and there's
A lot
not
of
enough
land,
people.
still, there's a fair amount of land development and they're building smaller plants, but it's still taking labor, skilled labor. And then,
So how about this? I will find out.
Yeah.
I do not know exactly, as I said, this is not my area of expertise, but this is what they had sent it to me to show it to you all. So I'll go back to them and ask them, what is the fair analysis? If they need to update that, I'll let you all know.
I mean, to Brad's point, you can flex these around. There's a place where the line will cross and you go, okay, well, if we're wrong, you know, this is where it's going to happen. It's what's going to feel like, right?
I'll talk to them about the sensitivity analysis. But that's all I had for today.
Well done.
There's no, well, it's the same.
If you had inflation and cost, you have inflation in revenue.
Yeah, but it should be the same for all.
You've only talked about the capital escalation factor. How about the O&M escalation?
So we are looking at only the capital cost, capital investment right now as part of the NPV.
Well, for a true cash flow analysis, you've got to. Because one alternative is capital intensive and the other alternatives are labor O&M intensive. And so you need to balance the two. And that's what NPV does.
Right.
If you're only looking at capital and you're missing this.
Bob,
half
you're
of
talking
the
about the
equation.
labor during construction, or are you talking about the labor?
Yeah,
Okay.
O&M.
Okay, Bob, just being clear.
If they look at their MCAD, you know, what I call it, what's your MCAD system? Where you keep track of maintenance activities, you have your R&R budget. You can look at that over the last 5 years and see what the escalation factor is. You can you kind of know what it's costing to maintain the plant currently. And you
Currently, but I don't know about the new plant. If we go to new MBR technology,
Yeah, and we'll look into that again.
We need to have that
Yeah,
other
sorry.
half.
Are you proposing that NBR plant have a much higher O and M cost?
Lower,
Lower.
much lower. It's more capital intensive, but the O and M will be lower.
Out past 25 years.
Bob, I'd like to ask a question to the board. How many people think that the SFDU design criteria that they use is correct after tonight? So I'll take that as nobody agrees with that they haven't used the correct SFDU numbers.
I would say it differently. They've used what we gave them and we probably need to reevaluate it.
Thank you.
Thank you.
So
Right.
that's
Well,
good way to put it, but what I want to say is that what I'd like to do, I made a proposal that in my email that we have somebody on the staff of the River Authority, on our staff, which Kim would be real good because she's familiar with SFDUs over in South Montgomery County Mud, and I'd like to be involved since I have gone through this once, and that we get together and see if we can't resolve in-house. Don't hire somebody and postpone this May 8th meeting until we can come back. The three organizations, the MUDs, Woodlands Water, and the River Authority, after we've had a chance to review all that data and come up with what we think is a acceptable number. That's all my only comment.
I think we also have to know, if we're gonna say that the current SFDU is not correct, we need the basis of how it was all put together. All right, so we can compare it to your proposal.
Well, that's what we'll be looking at.
Well, we have to ask them for the data, okay?
No, that's, I assume
And,
that
and share that back.
you're right.
And if we want to go forward, we should go forward with a policy. Are you recommending that the trustee board make a policy tonight on your proposal, how to move forward?
Well,
We're a policy board, right? If we want to improve our direction, which it sounds like you're proposing, then the board should consider that and vote accordingly.
I'm proposing that we, I'll make a motion that we postpone the May 8th meeting until we have a chance to reevaluate the SFDU criteria that were used by previous consultants.
I'll second that so we can go into any discussion that we may.
Okay, we have a motion, we have a second.
I'd kind of like to share some of this with my MUD directors themselves and just kind of get them caught up to where we are possibly. Rather than just
That would mean postponing the meeting, or would it not? Because won't you?
what's going to happen in May 9th? What's the next kind of
What's the
round?
next-
May 8th, we were going to talk through each of the alternatives in details, the layouts. Also talk through the cost of each of the alternatives. And our plan was to also show you the evaluation of all four alternatives, but it looks, we may, if folks are not ready, it will be a very long meeting because there is a lot of data to go through. We could,
But the problem is they're using, they're using what I think is the wrong capacity.
So once again, you're using 7 MGD, right? Because that was what came out of the facility master plan. So you're using that consistently throughout. So, earlier when I stood up here, I think one of the things that we could consider would be for us to, in the PER, for whatever selection that we make to move forward, you can revise the capacity at that point, or we can really look to the Woodlands water to bring back an SFDUE that you would like for us to use as we move forward. We can do this, but I don't think we necessarily have to delay moving forward just because you disagree with the 7 MGD. That's going to give a baseline of what the 4 different alternatives could be designed around. So
It sets the top limit.
Wait a minute.
Go ahead, Ed. Go ahead. I
Go
know
ahead.
you-
because the peak flow is what the peak flow is
Well, in
that
other
comes
words,
through.
Well, in other words, you're gonna design for peak flow and you don't really care what
Well,
this.
right now, our proposed contracts for what we have to deliver for you is in that 5.85 area. And we would make recommendations to have a buffer on top
But
of
that's
that.
part of the problem. We don't know whether that, you've got that 1.7 of sold but not used, or we need to resolve that number. Sold but not used. And that's a big piece of 6. That's almost.
So I was just offering the alternative that I threw out earlier, so just for discussion. Yes,
I
sir.
don't know why we're plowing ahead and having all these meetings.
Made a motion.
Plant.
Made a
I've got a
motion.
motion.
And you have a second, and we're in discussion.
So let me also, I mean, I support what Ken's proposing, but I mean, so much of what we saw tonight said it's good for 10 to 20 years. We're having this big debate on what the capacity is going to be in 10 years. If we can defer building something for 10 years out, then we'll know what the capacity is. Okay? So there's a tremendous advantage to delaying building until we get resolution on what the capacity needs to be. We can continue to maintain, repair, and operate the current plant, stay within the current permitting limits. And I think their storage solution was a very good solution. Okay? You get a bunch of stuff grandfathered. You don't have to go, the whole plant doesn't need to go to 28. 10 years from now, we'll know whether we're actually producing 7 million gallons a day of effluent.
Well, there's also the analogy too, in your car, it gets to the point, you're putting more and more money into a car to repair it, to get more years out of it. And at some point, you're better off buying a new car.
Oh, certainly. And I think in 20 years, we'll be there.
Yeah.
But we're not there now.
We're not there now.
It's a 2-part motion.
Well.
You wanted
No, I
to
just postpone the meeting until
But-
we resolve it, and then we can move forward. But that's my motion, is we postpone it until we get together and, you know.
But he's made a request that we go back to our MUDs before we.
Yes, I agree with that because the contracts are with the MUDs, not with Woodlands Water. Is that correct? The contract.
Yeah.
For wastewater treatment are with, all with MUDs,
With each
individual
MUD.
MUDs.
At 217 gallons per connection.
Correct.
So, but that
This
means
is
you
a-
agree with,
This is a discussion, I'm thinking, getting some advice from our MUDs.
Our directors would be interested in this whole conversation.
Yeah.
So what you can do is, if Kent wants to modify the motion, at least postpone the May 8th meeting, take it back to the MUDs, and then bring it back to the next trustee meeting and determine what the next steps would be. But if Kent would modify that motion like that, then
I think you're saying basically that, you think we need to complete the
Well,
SAU study before.
Hopefully, you
I don't know
know,
what I would take back right now other than watch the tape. It's been a good meeting.
if we
We
postpone for the
need,
month,
we
the
need to
next
resolve
month
the
meeting,
SMU amount.
that we could have.
And I don't know if that's a month after or 2
information
months after.
together. I mean, it's not, you know, they've already assembled it. We just need to look at it and figure out, come back to the individual MUDs and.
So
I'll be
we'll have
happy.
another board of trustees meeting and then the next round of MUD meetings.
No,
right?
if we're gonna postpone the
Yeah,
May 8th
right,
meeting,
right,
have
right,
another
right.
round of MUD meetings.
Right, which will be in June.
June.
Yeah,
Huh?
and then we can, if we can get the 3 of us together, if they'll agree, I'll do it myself, but, you know, my credibility sometimes gets questioned. So, what we really need, to be honest with you, Ed, is you've got, you know, you have I don't think you've got anybody in your technical services group that's been here for 7 or 8 years. Well, I'm talking, I know Chris has been here long. I'm talking about somebody that know and learn the Woodlands backwards and forwards.
We have multiple staff in my technical services group that have been here for 14 and 15 years.
Okay, good. Then can we get one of them to work with us to look at the SFDU information?
We can discuss it, yes, sir.
Okay, good.
Please.
Okay, I have a
Question on
I have a
postponing
concern.
the May 8th meeting, please, Bob. One
Because
last thing.
we're talking a lot about SFDUs, but a lot of the design has to meet peak flow requirements. And so there's a difference between the two. And you could drop the SFDUs down to 50 but you still have the requirements from the TCEQ and the peak flow.
So everything I showed you guys
It's
was
storage
the peak to flow hour.
But was that 4 point or
Doesn't,
2?
no,
matter.
it was not
Okay.
4 point. It was the actual
It's actually
flow
going
coming
through.
into
Okay,
the plant.
Okay,
So the peak flow is realistic. What you're seeing, the 28 MTD coming into the plant is a realistic flow.
well,
That's reality. That's what's really happening, whether we like it or not. That's happening, right? We got to deal with that. And the storage tanks, we got some repairs that you've identified, which kind of gets things going in the right direction. In the meantime, we figure out our SFDUEs and figure out what the heck do we actually need, and we don't have to go to May 9th meeting.
So
Or 8.
that's the,
Is that it? We there now?
to just postpone the May
Let's
9th
end
meeting.
that with that discussion.
Yeah.
I'll make a motion to postpone the May 9th meeting.
Okay.
May
We have a,
May
we have a motion and a second. All in favor signify by saying aye.
Aye.
Opposed? Abstain? Motion passes. We won't have the pleasure of your company next month.
Thank you very much.
Keep working. Keep working.
By putting,
Is there any, oh,
time out, please. By putting the SFDUE back into another analysis, that potentially changes some of the analysis that Rolo is doing, could change cost estimate that they have already prepared. So this is additional work, additional scope.
Well, it's just work the SF. I understand.
I would say,
But,
That's the whole idea.
but basically, we're gonna ask them to
Change order?
Pause.
yeah,
Pause.
yeah, it's a pause.
okay.
But I didn't
hear that the
SFDUE was part of that motion.
No, it's not.
Why would we? if we're gonna
Modified.
change
The motion was modified, right, Ken? Just to postpone the all mud meeting on May 8th. Right?
And then we'll
Yeah,
bring,
board meetings
bring
in
the
May.
SFDUE discussion back to the individual MUDs.
Yeah.
Change the sound.
And I'll have something to share on that.
Studies.
Well, the software that, the build up to GIS that we show. It will align nicely with this conversation.
Any, before we adjourn, anything else to be brought up on our next Board of Trustees meeting? Placement on future agenda?
So what's the path forward on the SFDUEs? Are we getting
Just bring it to the mud.
To the MUDs.
we're gonna bring it to the MUDs, whether we want to reanalyze them?
Seems like some information Eric wants to share regarding.
His is not
It's
close.
just- It's close.
Is it close or not
May
close?
not be quite there, but it's close.
So we'll have some insight at the MUD meetings on what kinds of changes could occur.
Yeah,
We'll have something to work with.
the tools that were utilized to build the sixth and final.
Yeah.
Which were the softwares that were used are obsolete. We
Okay.
can't get at that data. Okay. I've been recreating it with
Okay,
our GIS software consultant. And so a week or so ago, they completed at least the buildup of it. Now it needs to be calibrated and cleaned up so that it can do what we're talking.
right.
But we haven't had the ability to do that until now. So we're real close to that.
And I was thinking that we were gonna go to our MUDs in May, kind of get them all caught up to where we are today and introduce this, saying that we think this has to be resolved. If there's something Eric's team can share, then we have to commission a study. And I don't know if that recommendation is the right way to tackle it, I don't know, but there's something we have to do to get our SFDUs in a place where we all agree with, right?
I mean, are we asking Eric to come to our MUD meetings in May with a update on
If
that?
he's ready to share something, that would be great.
And that'll be individual MUDs and a view of all the MUDs and how they fit and which we plan on.
And our action as trustees is to come back from that May MUD meeting with a
In June.
Kind of a plan.
June to say,
This is what our group.
our group wants to
Yeah, much like we did
rework
with
this
this other survey.
in more
yeah.
detail, or no, we're okay proceeding with what we've got.
That's the way I heard it, Brett.
Okay, so that's a
Right.
June trustee agenda item,
Correct.
which is to be the
Yeah,
trustees
that
report
needs to
back.
Yeah.
on
Yeah.
this.
Yeah, okay. I just want to make sure what the timeline
We're all on
is,
the same
and
page.
expectations
Yeah,
for
yeah, yeah.
trustees and directors. and
June SFDUE discussion. From the input gained at MUDs. Good.
Okay.
Further additions? Meeting's adjourned. Thank you very much.